Hi, today I'd like to share with you three key lessons that I learned after managing a fleet of Kubernetes clusters for over 8 years. The three learnings I'll go over in this presentation are evolve your platform, create an appropriate level of abstraction, perform operational review of your key performance indicators. I work at Adevinta. Adevinta builds online marketplaces across Europe. To support the business, my team and other platform teams have built an internal platform, the common platform. This is a bird's eye view of the common platform. We pick components and connect them together to offer a good experience for developers. Components like Kubernetes or GitHub Actions could be replaced by other options if the teams thinks they have alternatives that better fit their goals. So essentially, developers can focus on features, and the common platform helps them deploy, maintain, observe, and keep applications secure. Today, I want to share my experience running the runtime layer. Building an internal platform has a lot of angles and nuances, so I want to focus on a small part of it. If you want to know more context or details about our internet development platform, please watch this talk from a previous edition of PlatformCon by Carlos Navarro, a farmer in Adevinta. So my team, the runtime team, maintains SHIP. SHIP is a multi-tenant, multi-region, multi-cluster Kubernetes as a service internal platform that comes with managed features like ingress, observability, autoscaling, policies, and much more. And is nowadays widely used in Adevinta. But it wasn't always the case. This graph shows the evolution in the scale from SHIP in the past to the present day. When we started, we maintained the whole stack, the control plane, workers, cluster applications. In 2022, we decided to migrate all clusters to EKS to reduce our operational load and focus on feature, which also explains the latter explosion in the number of clusters. We added more classes and regions to reduce the blast radius, and the difference in scale from 2017 to 2025 is enormous, from 1 cluster to 29, from 5K requests per second to more than 300K. During this journey, my team and I learned three key lessons that help us navigate all the changes. Evolve your platform, create an appropriate level of abstraction, and perform operational reviews of your key performance indicators. Evolving your platform will help you modernize your cluster and accommodate changes. Evolution has multiple aspects, but I'm going to discuss the most frequent evolution when talking about Kubernetes clusters, cluster upgrades. At the beginning of our cluster upgrades endeavor, when we upgraded from 1.6 to 1.9, we decided to take the blue-green approach. We created a new cluster in the new version, deployed cluster user applications in both clusters, and gradually shifted the traffic from the old version to the new one. That approach gave us control over the upgrade and a quick rollback if needed. The problem with this approach is that it can create a lot of toil for the platform team, since you need to coordinate with users when to do the migration, follow up on problems, improve the process, etc. The URL listed is Traffic Controller, an open source operator that we have developed to help with the blue-green traffic shifting. Please check it out. An alternative to the blue-green upgrade is to perform it in place. Instead of creating new clusters using a new Kubernetes version, you will create the existing one. Update the control plane and replace the nodes one by one using the new version. Doing upgrades in place is a big bang event and a scary one, since once you start the process, it cannot be stopped. Once you start the process, it cannot be rolled back. Since new versions can introduce API breaking changes, we have created this dashboard that shows us how many objects in a given cluster will break if we upgrade that cluster to a target version. This dashboard allows us to analyze if it was safe to start the upgrade in place. Nowadays, you can have similar insights natively in EKS and GKA and probably other cloud providers, or you can build your own. Obviously, even when the dashboard doesn't show any problem, we will make the upgrading phases from low risk, low traffic to high risk, high traffic. This table summarizes our experience doing cluster upgrades using both strategies. Blue-green helped us a lot in the early years when new versions come with several breaking changes. The downside of this process is the disruption for users, at least to coordinate the dates when to do the upgrade, and increase operational load to the platform team, to the point that at times we dedicated the whole team to do cluster upgrades. Doing a blue-green upgrade is also costly in time. A given upgrade can span over months due to problems coordinating the upgrade with users. Once we moved to EKS, when extended support didn't exist, we feared a forced upgrade. So we changed the strategy to do it in place, because it has the benefit, the immediate benefit, that is way easier to coordinate at least the upgrade date. This achieved no impact on users and reduced toil in the platform team after a few tweaks in the process. If you want to know more technical details or the tweaks in the process, you can take a look at Tana's blog post, a colleague from the runtime team, which covers the upgrade process in detail. Another part of platform evolution is introducing new features. This is one example of the life of a new feature in SHIP. One day, a team came in 2022 before EI asking us if they could use GPU instance to serve machine learning models. We replied that we didn't have the feature at the moment, but it was doable. At that moment, we could have done a hack or a custom development for enable the feature for that team. But in my team, we load custom developments. Since they introduced connective load, we need to remind and remember what we did there differently, and drift. When we do to evolve the classes or add new features, we need to take into consideration that we did a custom development or hack for a given feature. So we look into a way to introduce this feature for any team with the right interface. When we introduce new features or change existing ones, we don't do it all at once. We do it in a progressive way using the Argo CD progressing feature. Starting first in the cluster where the team that requested the feature first is placed. This allows us to identify problems when rolling out and also monitor performance, reliability in a way that reduces the blast radius of changes, since only a subset of clusters will be affected or will have the new feature. Maturity levels. To set the expectations regarding support, availability, and stability, we have defined maturity levels. This allows the runtime team to introduce new features in a way that our users can know what is the current status over time of a given feature, like GPU on chip. Since we set expectations regarding stability and support, we can offer the team that requested that feature an alpha level initially and ship mature that feature over time. It's also essential that you have a plan for deprecating features. It is not rare that you find out that some features are not as used as you expected or have been replaced by new technologies, and you need to have a way to deprecate them the same way Kubernetes deprecates APIs. Since we set the right interface, define how to mature and deprecate the feature, and deploy it progressively, we have completed the life cycle of a feature when evolving the platform. Let's move to another key learning. Create an appropriate level of abstraction. When defining an interface or supposing one, we need to suppose it at the right level. If the abstraction is too high without providing escape hatches, will make it hard to adapt and users will avoid it. We have an example in SHIP. In SHIP, we sponsor FiaaS. FiaaS is an open source operator that aims to reduce cognitive load for developers, allowing maintainers to set same defaults. We set and we declare FiaaS as the recommended interface to deploy applications in SHIP. In the right, you can observe an example of a FiaaS application object. It's a CRD. As part of the spec, you will see that there are fields that looks familiar to other APIs, standard ones like deployment API or ingress API in Kubernetes, but they are all summarized in the same object. What happens if one user wants to add a sidecar in one FiaaS application for some valid reason, like introducing a network proxy or adding a log collector? There is no place for sidecars in the spec, so it is not possible. Yes, we can contribute support upstream, but adding it to the spec might go against the goal of exposing a simple interface for developers. Let's see an example on the other side of the spectrum. A tool-low interface will empower users to use whatever is possible, but will make the interface harder to change and replace. One example of this is the nginx ingress controller. When we started SHIP in 2016, there weren't many ingress controllers available, so we picked nginx as our default implementation. The majority of applications running in SHIP interact with ingress through the standard API, through the Kubernetes ingress API. However, some applications want to change or add something that is not present in that API. In this case, for instance, one example, a user wants to add a new header at ingress level, not in the application level, at ingress level, modifying the ingress object. The nginx ingress controller provides a special annotation that allows users to put extra configuration that will be passed to nginx. In 2016, we decided to allow the user to use this annotation because we thought we could always replace the ingress controller later, and it's not a big issue. Jump to 2025, when 34% of our ingress objects uses ingress annotations to tweak and configure nginx behavior. We know that we are tying ourselves too much to nginx, but it's fine because we think we can always replace it with another ingress controller implementation. It's fine. Setting the right level of abstraction that helps users reduce complexity while allowing maintainers to change the implementation is very hard. But it's important to know knowledge at which level you have your interface. Our last key learning is to perform operational reviews. As a platform team, you need to define the key platform indicators, KPIs, that makes more sense to your team. Those are the KPIs that ship uses. You need to set up a periodical operational review of those KPIs to assess the healthiness of each metric, analyze past failures, and create actions to improve based on the review. Our KPIs are service level objectives. We have SLOs on Kubernetes API, ingress, DNS, IAM credentials, and pod scheduling. Cluster efficiency. I will show an example in the next slide. On-call pages. I also will show an example in the next slide. Support requests, where we measure the volume of support requests received, and if it increases, we try to see if there are some trends or clusters that we can act and reduce it. And cost, where we check actual expenditure versus the budget, and if there is a huge drift, we analyze it and take action. This is one example of a KPI, cluster efficiency. Here we have a dashboard that measures the percentage of CPU and memory used in cluster applications and applications that are part of ship compared to user workloads. Ideally, we want to keep that number as low as possible. And if we see spikes, it's because there is clearly a misconfiguration or a bug. Another example is on call pages. You can see in the chart there that there are spikes, but eventually recover over time. And at the end of the chart, you will see that it's more flat or following a downward trend. This is the result of the periodical review, focusing on making on-call healthier and taking actions to analyze what can be done to reduce pages. And that's all. Evolve your platform, set the appropriate level of abstraction, and perform operational reviews are my key learnings after 8 years managing a Kubernetes platform. Reach out to me in Slack if you have different learnings or want to know more about your experience. I also want to thank you, my past and present team, for helping me with their efforts to discuss this topic here today. Thanks.